We didn't know something we didn't know that you wanted it. You wrote on paper, didn't you?
Yeah, I completed it on paper.
Okay, well, go get your paper. Tell them we didn't know we wanted to send it on the online.
We didn't know we were supposed to send it online.
Okay. You could share that homework on WhatsApp group or via mail.
Tell them that you wrote on paper.
I wrote it on paper.
Okay.
Where is it?
That's what I'm thinking, because I figured out where I put it. It was a black pen that I used.
It was on here?
No.
Oh my god, honey, be prepared. Can you just stay in class and I'll look for it? Is it in the
You can
notebook?
share it now if you are having that paper with you.
I, I, I don't know where my paper is.
Um, you forgot that paper?
I'm sorry, what?
You forgot that paper, keeping it somewhere?
Yes.
Okay. All right, then let's work somehow in a different way. Okay, then let's go ahead with something else.
Okay.
Honey, be prepared next time.
Okay.
So, Hooni, last time we discussed some questions in Vedic mathematics. Okay. Um, let's go ahead. I'll be sharing something with you today that is in the form of book. We'll be discovering more concepts now formally. Okay. So let me just go with that. Just let me know if you can see my screen.
Okay.
Is it visible now?
Yes.
Yeah. So this is about arithmetical computations.
Yes.
So we are going to talk about it formally because this will actually help you strengthen your concepts.
Okay.
We discussed all the things informally and we talked about some basic concepts that may strengthen your mental mathematics. Today we'll be talking everything from today onwards formally in the form of book. Okay. So this is basically a book of Vedic mathematics. We are jumping to chapter 2 because chapter 2 starts from very basic and chapter 1 is basically an advanced approach. So I would like you to read some basic stuff, then we may move. Go ahead with this.
We now pass on to a systematic exposition of certain salient, interesting, important, and necessary formula of the utmost value and utility in connection with arithmetical calculations, being with the processes and methods described in the Vedic mathematical sutras.
Yeah. So this is about Vedic mathematical sutras, and we are talking about systematic exposition of certain salient, increasing, important, and necessary formula. As like we talked about complement, if you may remember, like I told you, the complement is a value which is different difference of that number, particularly from nearest value of 10 power something. Like for example, can you tell me what is the complement for 98?
Hmm. Wait a second.
What makes 9800?
Oh, two.
2. So 2 is the complement. You remember that thing or you forgot? Okay, let me just go with some of the stuff so you may remember that thing. Like I just told, like, what is the complement for 78? Complement.
22.
Yeah, 22. Right? Because this is going nearest 100. And if I ask you what is the complement for this 712?
290. Well, no, 288.
Yeah, I told you the way, like how to find complement. Subtract each number from 9, but the last digit would be subtracted from. Do you remember that thing?
1.
No, subtract each number from 9, but last number must be subtracted from.
10.
10. Yeah, that was the case we went through in our uh, beginning classes. Do you remember that, or you've forgotten?
I remember.
Okay, so this is something which we covered already. So we are covering more, and we are calling it Vedic mathematics sutras, because we this is nothing but Vedic mathematics that helps you strengthen your concepts in um, mathematics mentally. So let's go ahead, and you may read this at this point. Yeah, read from here.
Um, himself
At this
do
point, at this point, from here,
which where
from
oh
here.
do all the requisite
Where are you reading? At this point, it will not be out of place. From here, you need to read.
it says do
Hmm. At this point, it will not be out of place for us to repeat that there is general formula which is simple and easy and can be applied to all cases. But there are also special cases, or rather types of cases, which are simpler still and which are therefore first dealt with. Now read from here. We may.
do all the requisite multiplications involving bigger multiplications and multipliers with the aid of the relevant simple Vedic formulae which enable him to get at the required products very easily and speedily, nay, practically immediately. The sutras are very short, but once one understand them and the modest operandi involved therein for their practical application, the whole thing becomes a sort of child's play and ceases to be a problem.
You just I guess, where did you start reading? You started reading from here. We may. Can you see this?
Started at do.
But you had to read from here. We may. Can you
Oh,
see this?
yes. We may also draw the attention of all students and teachers of mathematics to the well known and universal fact that, in respect of arithmetical multiplications, the usual present day procedure everywhere in schools, colleges, and universities is for the children of the primary classes to be told to cram up or get by heart the multiplication table is up to 16 times 20 times 20 and so on. But according to the Vedic system, the multiplication tables are not really required above 5 times 5, and a school going pupil who knows simple addition and subtraction of single digit numbers and the multiplication table up to 5 times 5 can improvise all the necessary multiplication tables for himself at any
Yeah.
time.
So that's what we had covered. So this is saying nothing but this is just simply telling us the ways that how we can actually mentally go through the mathematical calculation in the form of tables, and we need not to cram the tables, but we need to understand that, and will be able to find the table in magical way. So there are some steps we need to follow. So step number one, you can see. So can you read from here? Let us.
Let us first take up a very easy and simple illustrative example, i.e., the multiplication of single digit numbers above 5, and see how this can be done without previous knowledge of the higher multiplications of the multiplication tables.
Yeah. So these are the things which are which would be called as sutras, and this is something, the first sutra we are going to cover, that is called Nikhilam Navascha- Navatascharam Dastah, which actually means, translated into English, all from nine and last from 10. So you may write this on your sheet, the heading, all from 9 and last from 10. Write this thing. We are
Okay.
going to talk about this thing. All from 9 and last from 10. Can you see this?
Yes. All from 9 and last from 10. We shall give a detailed explanation presently of the meaning and explaining the actual procedure step by step.
Hmm. So that is the thing, like we just followed. I also told you like everything you must subtract from 9, but last number should be subtracted from 10. That is what we have done, finding complement of each number, right?
Yes.
So you may write this title on your sheet, all from 9 and last from 10. The last from 10. Have you written that?
Yes.
Write this, all from 9 and last from 10. We'll be doing some questions with this.
Okay.
Okay, so we shall give a detailed explanation presently of the meaning and application of this cryptical sounding formula. But just now we state and explain in the actual procedure step by step. So let us consider those steps. Suppose we have to multiply 9 by 7. Okay, so
Okay.
the first step says we should take as base for our calculation that power of 10 which is nearest to the number to be multiplied. So, what number in power of 10 is nearest 9?
Um,
10
one.
itself, 10 itself, 10
Um,
itself. Nearest power of 10. Do you understand power of 10 means basically what?
no.
10 to the power 1 is equal to 10.
Yes.
10 to the power 2 is equal to
100.
10 to the power 3 is equal to
1,000.
okay, 10 to the power 4 is equal to
10,000.
yeah. So this is something we need to do actually.
Okay.
Okay. So we what we need to do, we need to understand like we have to find the nearest number which is 10 to the power something. So now 9 is nearest which number which is 10 to the power something? 10 itself, because 10 is equal to 10 to the power 1, right? 9 is
Yes.
nearest 10, right?
Yes.
But if I ask you in two digit number, that would be nearest what? 10 to the power 200.
Yeah.
if i
Mm,
if I say not 9, if I say 88, then that would be nearest which 10 to the power number? That is 100, right?
yes.
And if I ask 777, then it would be nearest which 10 to the power?
3.
3. That means 1000, right?
Yes.
If I ask you 3433, that would be nearest.
Oh, 3.
There are four digits. 3343. Four digits.
Okay.
Then 10 to the power 4 it would be, right?
Yes.
Okay. So we are talking about the same thing. Observe the things very well. Suppose we have two numbers and we have to multiply 9 by 7. It means 9 multiplied with 7. Okay. So 9 is nearest 10, right?
Yes.
7 can also be nearest 10. We need to find complement of 9. That is 1. Is that true?
Yes.
What is the complement of 7?
3.
Very good. So we should take as a base for our calculation that power of 10. Base would always be equal to power of
10.
10. Very good. So write just now. You have written the heading. So
Yes.
remember, um, write it.
Okay.
We should take as a base. We should take as a base for our calculation. Right. Step number one. Uh, we should take as our base for our calculation that power of 10, that power of 10,
Okay.
which is nearest the numbers to be
Yeah.
multiplied, which is nearest to the numbers to be multiplied.
Yes.
Okay.
Okay.
All right. So this is the step number one we'll be following in each case. Okay.
Yes.
And then right second step, put the numbers, put the numbers which are to be multiplied. Right. Second step,
Yes.
put the numbers which are to be multiplied. I'm speaking, just write it down. It will help you revise the things.
Okay.
Second step, put the numbers which are to be multiplied, put the numbers which are to be multiplied
Okay.
above, above and below on the left hand side.
Okay.
Okay. Now third step, right? Third step,
Yes.
subtract, subtract each of them from the base
Okay.
and write down the remainders on the right hand side
Okay.
with a connecting minus sign, with a connecting minus sign.
Okay.
Okay. So that's what you need to do with a connecting minus sign between them, right? Between them.
Okay. Okay.
Done. So and now fourth step, right? Fourth step.
Yes.
The product will have two parts, one on the left side and one on the right side. The product will have two parts, one
Okay.
on the left side and one on the right. The
Okay.
product the product will have two parts, one on the left side and one on the right.
Yes.
A vertical dividing line may be drawn for the purpose of demarcation of the two parts. A vertical dividing line. This line, dividing line, this. A
Yes.
vertical dividing line may be drawn for the purpose of demarcation of the two parts.
Yes.
A vertical dividing line may be drawn for the purpose of demarcation of the two lines, two parts. Okay. Is that done?
Yes.
Now, fifth step. Now, left hand side digit can be arrived at in one of four ways. Now, hand side digit of the answer can be arrived at in one of four ways.
Yes.
Now, write way number A, number one. You may write number A. Subtract
Okay.
the base from the sum of the given numbers. Subtract the base from the sum of given numbers.
This one.
Of given numbers.
Okay.
And put put them
Okay.
at left hand part of the answer. And put them at left hand part of the answer.
Okay.
Uh, or right, or B point means second method. B, subtract the sum of the two deficiencies. Subtract the sum of the two deficiencies two deficiencies,
Okay.
you get the same answer. You get the same answer. Or write C method. C.
Okay.
Cross subtract deficiencies. Cross subtract deficiency on the second row from the original number. Cross subtract deficiency on the second row from the original number in the first row.
Okay.
And you find that you have got the same number again. You found that you have got the same number again.
Okay.
Write D or D, cross subtract in the converse way,
Cross.
and you get the same answer.
Yes.
Now see the logic. You will be writing example. So write an example. An example is this time. Write this
Yes.
thing, this whole thing. Firstly, you'll
Okay.
be writing 9 and then minus 1, 7 minus 3. Then you will put a bar and you will write both of them and let us now understand. Firstly, write it, then we'll understand.
Okay.
You may write somewhere this shows multiplication between 9 with by 7.
Seven.
Okay, 9 into 7. Okay, so this value we need to find. This value we need to find. Okay, so here we see this is the same method which we have completed. We have understood in previous classes. Do you remember those things or not?
I did.
Yeah. So how come this one has arrived? Can you explain if you remember?
Because 9 minus 10 is 1, and then 7 minus 10 is 3, so that's why there's a 1 and 3.
Yeah. So this is basically what complement, right?
Yes.
Because the base value, the base nearest, this 9 is in the 10 to the power something, that is 10 itself, 10 to the power 1, right?
Yes.
Base value depends on the number of digits. If there is one number of digit, then that will be 10. 10 to the power 1 is equal to 10. If there is two number of digits in the number, that then the base value would be 100, right?
Okay.
And if there are three digits, then the base value will be
Um, 100.
1000. 3,
Oh,
1000. 10 to the power 3 is equal to 1000. If there are four numbers, then
10,000.
10,000. Five numbers, then
100,000.
100,000. Good job. So we understand this is one is complement and this three is complement. So what we need to do, we understood last time. Either we can go with this method. You simply do cross subtraction. Subtract 3 out of 9. This will become 6, right?
Yes.
But today we understood some more methods. Either you can do this job also, like you the part you got as complement, you may add both of them. What is the value? What is the value? 3 plus 1
4.
or 1 plus 3, that is 4. When you
Yeah.
subtract 4 out of this 10, that base value, what you get?
6.
6. So again you got 6. So this is another method. You have written more methods in this way, right? But
Yes.
I like this method personally. I don't know what you like because this is very easy. So 9 minus 3 is equal to 6, or 7 minus 1 is equal to 6. You can go with this, right?
Yes.
I would go with that method which would become easier for me. So in this case, 7 minus 1 was easier for me, right? So this cross subtraction thing, you understand? Like 9 minus
Yes.
3 or 7 minus 1. This thing, do you understand?
Yes.
Okay. So this is what the half answer is achieved. That is 6. And how we will find this 3? How this 3 is found? Can you tell me?
9 times 7 equals 63, so the next number would be 3.
No, 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 no. We are not just calculating with table. We are going in different way. So the 9 minus 3 is equal to 6. How this 3 has been found with 1 and 2? 1 and 3,
Uh,
sorry. This was what? You remember that thing or you forgot?
1 plus 3 equals 4, and then the 4 minus 7 is 3.
4 minus 7 is 3. What do you say? No, that doesn't work in that way. We just subtract this number out of this, or we subtract this number out of this. We get 6 at one part, and then we multiply these two numbers, and then we
Yes.
get the value this, right?
Okay.
Same we had done in this thing, like 98 and 97. Can you do this one? This will be minus what? 98. This will be minus what?
Uh, 98. 1,
No, the base value would be what? Firstly, let me know. There are two digits.
2.
Base value.
98 would be 100 as the base value.
Yes. So now you may tell me the complement for this.
2.
2. We may also write 0, 2. Hmm?
Yeah.
And here, this side what?
0, 3.
Yeah. So I told you solving this. This is the same thing. And we may put this line to now what is the way? Either you subtract 3 out of 98 or you subtract
Uh, 2 out of
either
97.
yes, 97. So what you are getting here, this side,
95.
95. In both of the ways, like either you subtract this or you subtract that. And one more way we found today, you can directly subtract this, like just add both of them. That will be equal to what? 5. 2 plus 3 is equal to 5, right?
Yes.
And you can subtract directly from this base value. You will get the same thing, 95. 5 out of 100 is equal to what? 95, right?
Yes.
Now what you need to do in this side, what you will be doing?
2 times 3, which is 6.
So what we'll be writing, 6 or anything else here this side? Because two digits.
0, 6. 0,
Very
6.
good. So the answer is 9506, right?
Yes.
This is something we understood in our earlier classes, right?
Yes.
Yes. So I want you to go with this method formally now. So this is in the form of book, and we just discussed this problem, right? Okay. Um, so now let us do more. Okay. Did you understand this problem now? This one, but like this one was a small problem, 9 into 7. So this one is the complement and this 3 is complement. So this is nothing but 9 minus 3 is equal to 6, and this 1 into 3. 1 multiplied by 3 is equal to 3. So this is 63. The small problem, right?
Yes.
And why we are understanding? Because we need to deal with some other problems which are not nearest 10 to the power something, means which are not nearest base value. Then how we will be dealing with those questions we have to understand. So these are all the questions which you can directly do, like 8 multiplied by 6.
8 multiplied by 6.
You need to do with this method, not directly table. So 8, what is the complement for 8?
2.
The complement for 8 is 2, right? So we have written this side, and complement for 6 is,
4.
so we will just subtract. This one would be easier. 6 minus 2 is equal to 4, right?
Yes.
And how we found this 8? Can you tell me?
2 times 4 is 8.
Yes. So 48 answer. So in this way, we are just going. We are not using our table because we need to understand this method actually. Okay. And this process actually works in algebraical way. That is x minus a and x minus b is equal to x and then x minus a minus b plus ab. This is something this the representation shows. Okay. So now we will be going forward understanding each method each time. So now see this, like this is same as that is, but in this case what is happening? Try to understand. This is something like 10, the base value 10 has how many zeros after it? The base value 10 has how many zeros?
Uh, 1.
1. So you need to write always one digit this side. Only one digit. You are allowed to write only one digit this side, right?
Yes.
But in this case, now try to solve this problem. Can you solve your own? What is the complement for 7?
3,
3. What is the complement for 6?
4.
Okay. And what we'll be writing this side? Here,
Uh,
left hand side.
uh,
Subtract either from this or from this.
3.
3, right? But
Yes.
now this side, what will we will be writing? This side,
12.
12. But we cannot write 12 because they are two digits, right?
Yes, that means you have to add the 1 to the 3, which is 4. Then there's a
Yes,
2.
we will add 1 to this number that is now 4. So the answer is 42. Did you understand this concept?
Yes.
Very good. Very good. Well done. So now let us go ahead. So the base now required is 100 in this time because two digits. So the base value is required 100. This is what we have already done. So do you understand all of these questions you see on your screen? You may take a snapshot if you want.
Okay.
Do you understand all of these questions? Like how
Yes.
about first one? Can you explain the first one to me? That how it is being solved? Because I already explained it in the beginning
The
when we were
complement
doing. Hmm.
91 is 9,
Hmm.
so it's the same thing, so it's both 9. And
Yeah.
then 91 minus 9 is 82. And then 99, 9 times 9 is 81, so that's the answer.
Very good. Can you explain this to me? Second.
93, the complement of that is 7. 92, the complement of that is 8. 92 minus 7 is 85. 7 times 8 is 56.
Very good. Very good. Good job. Okay, so these are the things we already covered. Now we'll be going with something else. So here in this time, what do you see? Try to explain this problem.
Um, 88, 8, the complement is 12. And then that'll be 76. And then 12 times 12 is 144. So then you add one of the ones to 76. So then it turns to 77.
Why do we add 1 to 76? Why don't we write this side, right hand side? What is the problem writing there?
Because there's too many, uh, they can't be higher than the first digit in the, uh, in the first half. It can be higher than the first digit.
No, no, no. This is this logic. Like the base value for this is 100. So it cannot cover more than two digits because 100 has only two zeros. So it would be equal to the number of zeros the base value is holding, right?
Yes.
So because this is nearest which base value?
The base value?
Yeah. The base value for this would be 100, isn't it?
Yes.
Yeah. And this covers only two zeros. It means only two digits can be written this side. This side, sorry, 4 4, right? So one
Yes.
would be added here. Did you understand that concept?
Yes.
Can you explain this problem to me now?
Uh, 88, the complement is 12. 91, the complement is 9. So 91 minus 12 is 79. And 12 times 9 is 108. So then you give the 1 to the 79, which is 80.
Why do we give 1 to 79? Why don't we write it at right hand side?
Because you can't add any more to the left.
Why? Give me the reason.
Because because it has to be in the digit of the complement.
Yeah, in digit in the complement and the equal to the base values number of zeros, right?
Yes.
So what is the base value here?
Uh,
What would be the
20.
base value? Base value would be 10 to the power
Uh, of 100. 10
100.
to the
Yeah,
power of 2.
2. Yes, very good. 10 to the power 2, or you can say 100. I hope you
Yes.
understood this, right?
Yes.
Okay. So now see this. This is very important for you to understand because this is now going to be something different. With these three procedures for meeting three possible contingencies in question, where are you?
What?
Be concentrated,
Okay.
Hooni. So with these three procedures for meeting the three possible contingencies in question, that is abnormal, abnormal, and subnormal, number of digits in the vertical multiplication products, and with the add of the subtraction rule, that is of all the digits from 9 and the last from 10. All the digits are being subtracted from 9 and last digit is being subtracted from
10.
10 to find complement, right?
Yes.
Very good. Okay. Down the amount of the deficiency from the base, we can extend this multiplication rule to number consisting of a large number of digits, thus 888. So complement for 888 is equal to,
112.
yeah, all the digits would be subtracted from 9 except the last one. Last one would be subtracted from which number?
1000.
Last digit would be subtracted from which number?
Oh, 10.
10. Very good. So this is what we understood. So we can do more like going forward. All right. So that's what we understood. Yes, but in all these cases, the multiplicand and the multiplier are just a little below a certain power of 10 taken as the base, right? This is in all the problems we solved. This was near certain power of 10, right? Either
Yes.
10 or 100 or 1000, right?
Yes.
But what if in the case like which is not near 10 to the power something? Okay, we'll be doing that. What about numbers which are above it? Like, and the answer is that the same procedure will hold good there too, except that instead of cross subtracting, we shall have cross add. Like this problem. This is 12. So this is near the base value that is 10, right? 12
Yes.
is near which base value? 10, right?
Yes.
10. So now 10 plus 2 is equal to 12, right?
Oh, yes.
Okay. We did not use 100 law because 100 would be larger in this case. So we just went with 10, even there are two digits. So how it is followed, can you explain this question to me?
Uh, 12 plus 2
Hmm.
is 13. And then 2 times
12 plus
1.
2 is 13.
Yes.
12
Well,
plus 2
no.
is 14, not
11
13.
plus 2 is 13.
Yeah, this one. Why you did not subtract this time? Why are you adding it?
Because it's a 2 digit and then it's a
More
1
than
digit.
10. It is two
Yeah.
digit more than 10, not less, right?
Yes.
Very good. And this side, how would you explain this one?
2 times 1 is 2.
Very good. So it can be done in that case as well, like 111 and 109. So how would you multiply this? How did you do this? Explain this.
Uh, 111.
What base value you have used in this case? 10, 100 or 1000? Base
Uh,
value. Huh?
1000. Wait,
No.
no.
No, no, no. This is 11. So 11,
120.
100. Yeah. Even three digits, but we are using base value 100. Why? Because that is near 100. If you go 1000, then it would be more difficult, right?
Yes.
So now explain the question.
111 plus 9
No,
is
that is not 111 plus 11. That is 100 plus 11. 11 is equal to 111, right? 100 plus. Hmm? And this one, explain the second one.
109.
Yes, very good. Now explain more. How did you get the result?
Okay, 111 plus 9 equals 120. Then
Yeah,
11 times 9 equals 99.
yeah, very good. So you understood these things as well?
Yes.
Take a snapshot.
Okay.
Okay, now there is another thing. Okay, firstly, I'll ask you if you can solve these problems. Then I will just explain it to you. Okay, so let me just go ahead with this. What if I am giving you a different case? This side 97 and this side 103. Can you still multiply both of them?
Uh,
What will
yes.
be writing this side?
3.
Minus 3 or plus 3?
Plus 3.
Why?
Uh,
100 is the nearest base. Okay. So 100 minus 3 is 97 or 100 plus 3 is 97?
97 plus 3.
No, no, no. You will be subtracting from base. Base. You need to
Uh,
complete base. Complement. What is the
so
complement for that? Yeah.
100 minus 3 equals 97.
Yeah. So we'll be writing 03 because there are two zeros, right? We have to satisfy that need. Is that correct now?
Yes.
And what in this case? Plus or minus in this case? 103.
Plus
Yeah, very good. Because 100 plus 3. So zero
3.
three here plus, right?
3, yes.
Can you guess how we will be solving this problem?
Uh, 97 plus 3.
Yeah, it is equal to
100.
very good. But what about this side? What you will be doing this side?
3 times 3.
Yeah.
9. And then you add the 0.
Is this true answer?
Yes.
No, because this will affect. The symbol will affect. Negative 3 multiplied by positive 3. This would be what, minus
Positive 1.
negative 9. When you
Okay.
multiply this with positive value, this becomes negative 9. Do you understand that?
Yes.
So this is negative 9. How can you write it here? So what will you do? Can you guess?
Uh, you minus negative 9 by minus the 100.
By 100 from this number? You mean?
Yeah.
So what will be the answer?
Uh, 91.
91. And this side? This side
Yes.
what? This side
Uh,
91. What will be
yes.
the complete answer? Just give me the answer. 97 multiplied by 103 is equal to what?
91, 91.
91, 91.
Yes.
No, that is the wrong way. Okay, do you want to understand this now?
Yes.
So for this we have to understand the logic first. Then we'll be coming back to this question. Let us understand logic first, how it works.
Okay.
So, mm, where is that? Yes, this you can see. So here we see like this is 12. That is the what is the base value, nearest base value we are using? 10, right?
Yes.
So this is 10 plus 2 and this is 10 minus 2, right?
Yes.
So this is minus 4, right? So we have written bar 4. Can you see this bar here?
Yes.
So what you have done actually, see, the problem arrives here. You have actually subtracted this value out of 10. Sorry, out of 100 because this is what 10 and this one digit. So you have subtracted this, then this is 96. Let us understand each thing clearly by reading the theory. Okay.
Yes.
And we'll be coming back to the question which I was giving you. So read this theory. Yes, from yes, read it.
Yes, but if one of the numbers is above and the other is below a power of 10, then base taken what? Then the answer is that the plus and the minus will, on multiplication, behave as they always do and produce a minus product, and that the right-hand portion obtained by vertical multiplication will therefore have to be subtracted.
Yeah.
A vinculum may be used for making this clear.
What is vinculum? Vinculum is a bar you can see over this, right?
Yes.
So what it says the minus product will be found that the right hand portion obtained by vertical multiplication will therefore have to be subtracted. Subtracted from what?
Um, the other number.
Now that's what you need to understand. Look. So this is 10, right?
Yes.
So if we take a carry, so it will become 9 and 1 will go this side, right?
Yes.
But this is at tens place. So on not only 1 would go this side, it would become 10. If you put this thing this side, this will come with a 0. Remember that. Okay.
Yes.
So you have taken 1 out of it. This has become 9 and this has become 10. So 10 minus 4 is equal to what?
6.
So this is 96. Did you understand that?
Yes.
Okay, let's work in this question. Now let us understand second question. So same happened here. 8, 8 and like firstly this thing you must have understood. This is 105. You know how we obtained this?
Uh,
How? Hmm,
108 minus 3.
very good. And this we found like this is which symbol? Vinculum
Hello.
bar. So it means
Yes.
it is in negative, right?
Yes.
So now what we'll be doing? We'll be doing it, making it 104, and we will be giving 1 to this, right? And there are two digits. How many zero we'll be keeping here after 1?
Uh, 2.
2, right? But in this case, we only put 1 0. Why? Because there were only one digit, right?
Yes.
So this will be subtracted from 100. So what will be the data? You directly can tell me what is the complement for 2 4.
Uh,
9 minus 2 is equal to 7, and last one from 10. 10 minus 4 is equal to
6.
6. It means what you need to do each time in this case, you need to subtract 1 from here and you need to find the complement of this and just write it to here, right?
Yes.
Okay, can you explain this problem to me now?
So the complement of 49 is 1, but then you would also add another 1 because the complement of 49 is 51, and then 100 minus 1 is 99.
Yeah. Can you solve another problem if I give you? Then I will believe. The same
Yeah.
problem. Okay, this problem can you now solve?
Okay.
Okay, just tell me the steps. What will be writing this side? 100
100 and
and
then
hit this side 9 with a bar, vinculum bar, right?
yes,
And a 0 this side because this two digits we need to cover. Now what you'll be doing?
putting
This
the
side,
0.
this side
Okay.
what will be doing? This side, this data, let me know.
Okay. 99,
Very good. Now this side,
91.
very good. This is the answer. And what mistake you were doing earlier? Can you guess?
I put 91 on the
Both
99
side.
side.
Yes.
Yes.
So one side you will get -1 from the number which is there, and then another side the complement, right?
Yes.
Did you understand the concept or not?
Yes, I did.
Shall we do some practicals? Practice?
Sure.
Okay. So let me just bring to your whiteboard. Yeah. 97 multiplied by 102. Give
Yeah.
me the answer. Just do it on your worksheet and give me the answer.
94, 94,
94 and
94.
very good. Okay, have just done this following some method. Like, firstly, you may have done 95 here, and then you may have done like 3, like this, right?
Yes,
This bar represent that this is negative data, right? And then
yes,
you may have subtracted, and then you may have done like this. Sorry, no, not 3, this is 6, right?
yes.
Can we do it directly actually in mind?
Um, no.
Okay, I'm telling you the method to do it in mind. So we know we will be subtracting this
Yes,
because this is 97. So we already know this side, this is minus 3, and we know this is plus 3, right? Either we
yes.
can add it and we can subtract it. So if I just add the value 2, then it will become 99. Is that true?
Uh, yes.
So 99. But how did you get 94 answer? Wait a moment. No, 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 no. I guess that is something wrong. Something wrong you've done. Wait. Check your answer once again.
97 minus 2 is 95.
Why minus 2? That is not minus 2. That is plus 2, child.
Oh,
What will be the
98,
answer?
94.
98, 94, right. Now let us do it mentally. How you'll be doing mentally? Just observe. So this would be, this is 2. This is 2 above and this is 3 less, right?
Yes,
Our question would look like this, only this system, and we'll be working mentally how. So our question would look like this, and we have to observe it in mentally. So I said this is minus 3. This is because this is near 100 and this is plus 2, right?
yes,
So I'll give plus 2 to this. This will become 99. That is true.
yes,
But I know this is the case of plus and minus. So I would directly subtract in my brain. If my brain says 99, I would go with 98, right?
yes,
And I know this is 3 and this is 2. So it would be 6, 0, 6, right?
yes.
And I already know the complement of 0, 6. That is 9 and 6 is 4.
Okay,
How to find complement? That is the easy way. 9 from uh, every number from 9 and last from 10.
yes,
This is the way we find complement. Did you understand how I did it mentally?
yes.
Okay. So now you need not to use pen paper. That is the prerequisite. You need to just tell me the answer of this question. So 2 above, 2 less.
So,
96 your brain is saying, but you will do minus 1, right?
yes. So,
No, wait, no, not 96. That will be 100, 100, 100, 100. 100 is
90, uh,
99, 99. Because this is
90,
plus 2, the minus 1.
okay.
Yeah. You will
96.
9. No, no, no. Sorry,
Oh, no, 90, no.
that was a mistake earlier I told. So this is 2 less and this is 2 above. So we will add this. This will become 100, right?
Yes,
So 1 minus 100. That is 99.
yeah.
99 this side and this side 04. So what is the complement of 04? Tell me fast.
6.
Why 6? 9. This,
Oh,
this
96.
0, 0, 0.
Yes,
What will be the complement of 4? 04. 9, 6. 2 digits, right?
yes.
Okay, one more question. Just observe mentally and solve it fast.
Okay.
97, 104. 4 above, 3 less. So give 4 to it directly. It would be 101,
100, 101,
100, and then 1 less. Then this will
yes.
be 100. And this side,
Uh, 4,
12. Complement of 12.
Yes. Mm, I don't know.
This is the way we find compliment, isn't it?
Yes.
Simple. Tell me compliment.
88.
Yeah. Why do you confuse in compliment? Okay, let me practice compliment with you. What is the complement of this number? Do it fast.
29.
29. What is the complement of this number?
99.
What about this?
95.
What about this?
87.
So that's easy.
Yeah.
Okay. This. Do it fast.
Okay. mm, 100. And then the complement would be 404.
5 and 6. 5 and 6. 5 6 ja.
30.
Complement for 30.
70.
Yeah, this is the answer. Did you get the point?
Yes.
Okay. Solve more question mentally. Hmm.
100. And then uh 44.
104. And then 44. You said
Um.
this. This.
Yes.
Okay. This addition is easy. Look, give just 3 to it. This will become 100. And then minus 3 from it. Then this will become 5, right? So
Yes.
105. Are you able to solve these problems mentally?
Yes.
How is your brain functioning while solving it mentally?
Hard.
Hard. Now this time please note the homework and don't forget to submit it via mail
Yes.
or WhatsApp, okay?
Okay.
Done.
Yes.
Kindly submit your homework either
Okay.
on WhatsApp group or on mail,
Okay.
okay? Please tell your mom so she may remember that. Is your mom near?
Yes.
Let me know, right? Because you always forget this.
Okay.
Call her.
Mama.
Hello.
Hi, how are you?
Good. How are you doing?
I'm good. I just called you for a reminder. As he forgets sending homework, I want you to remind him sending homework either by mail or on WhatsApp group. Is that okay?
Okay. Yeah, we'll send it by email. Yes,
Yeah. All right. So it would
because
be
he
nice
doesn't
if,
have WhatsApp. So
yeah.
okay.
Okay. So he may send
Sounds good.
via mail. Okay.
Okay.
Thank
Thank
you.
you. Bye
Bye.
bye.
Bye, Hooni.